Hello everyone, in this video I'm excited to talk about the tooling that we developed with the Cash Ninjas project. So you can find our website at ninjas.cash, and this is an NFT project, an NFT collection for cash tokens, and it uses OpenAI enhancements. So each ninja has a unique name and also a unique background story. This is used as a description for the Cash Ninja. And the goal of this project explicitly was to develop open source tooling for NFT projects on cash tokens. So you want to help bootstrap the cash tokens ecosystem. And this is why you will find links throughout our website to the open source tooling that we have developed. So we'll take a look at our GitHub website in a minute. We open sourced all the code for this website, as well as for the tooling that we use to set up our Cash Ninjas mint. So it would be very easy for another project to replicate our minting flow with the Wallet Connect codebase and everything. So currently the supported wallets are Cashnize, Zapit, and Paytaka. So we hope to see more NFT projects using this tooling. One more open source technology that we are developing is a smart Bitcoin Cash bridge to cash tokens. So this will be open sourced and is the next item on our roadmap. The last one we delivered was this new collection page. The showcase collection page. So let's take a look at the GitHub organization. So this is the GitHub organization for the Cash Ninjas. And as you can see, this code has been written by Josh Elitorp, so ZQuest, and myself. And there is 4 repositories here. A minting contract, so this is the CashCrypt logic. It says multi-threaded minting smart contract for Bitcoin Cash. Then it has the repo for ninjas.cash, which is the website we just saw. And it includes everything. So it says Cash Ninjas Web3 frontend and minting website. Then there is, of course, the art engine that we use to combine in a randomized way the different layers that were created for the ninjas. So these layers are the background, the clan symbol, the primary color, the secondary color, the weapon, and the eyes. So these are all combined in a random way to assemble the different ninjas. And of course, in our collection, there is also hand-drawn specials, but this is optional. So let's take a look at this Shinobi art engine in a bit. But the last item is the Cash Ninjas API server. And this API server is what actually provides statistics such as these 1,312 minted. Also, it says if you go to this minting page and connect your wallet, it says what minting UTXO to use to the front end. And also it provides the metadata for the different ninjas. So if you go to the collection page, you check out the full collection, all these images and this metadata, it comes from the API server. And it carefully curates. So if you would go to the ninjas that haven't been minted, you can't see any of the metadata yet. So it also filters down which metadata can be released and which one still needs to be kept secret. So that's the role of the API server. So first of all, let's take a look at the Shinobi art engine. So this is needed to actually randomize the layers and get all these unique looking NFTs. So this is called the Shinobi art engine, and it's a fork from the well-known Hashlibs art engine that's popular for Ethereum. We forked this and added a bunch of features. So the first, of course, is BCH cash tokens support, so support for BCMR metadata. Then besides full images, it now also generates icons. There were some technical updates for the imports. We added a new examples using Shinobis. So if anyone wants to try out the Shinobi art engine, we recommend first running the examples to see how it works and playing around with the example. Then we also added OpenAI integration. So this is what we used for the different names. So for example, you can see here, Ninja 2 is Blaze Whisper, the Fire Clan Guardian, or Cyber Blaze Foresight, or Blizzard Shadow of the BCHI, and so on and so on. So this is what we use to get all the unique names. And if you would press on one of them and wait a second, then you can read the full description here where it says, "Meet Blaze Whisper, an embodiment of valor from the esteemed Fire Clan. With the backdrop of the serene village, Blaze radiates power with his primary color in mighty orange," and so forth and so forth. So each of these ninjas has a whole backstory and this as description. So this is also done with this OpenAI integration, which adds a lot of personality and fun to the NFTs. And besides that, there were a lot of code optimization and cleanup. So this code is all written by Josh Elitoip from our team. And he put a lot of work on providing extensive documentation. So you can see here how the installation works, which environment variables you need to configure, the usage with different examples, and how you can run it, and then the utils. And then it ends with, "Hope you create some awesome artwork using artwork with this code." So that's our goal. That's our goal by open sourcing all our tooling, that we will see some cool projects using this tooling on Cash tokens. So then next up, after the Shinobi art engine, is the ninjas.cash website. So let's take a look. This is the whole website you see here. So this is the two websites we just saw, are our NFT viewer and the NFT collection page. And as you can see, there's also the minting page and the home page, as well as a 404. And here is actually the logic in the JS and the JavaScript file, and we use Vite as a bundler. And here it has also extensive documentation on how you would run this and what the file structure for this code base is. Here you can see the installation and how you would use it. So to use this for your own project, you need an account at Wallet Connect on the Wallet Connect cloud, so you can get a project ID. And this is needed if you go to the minting page. This is needed so your Wallet Connect knows to connect to your unique project. And then it says, "Start up the web server and profit." So we hope people can use our code and documentation to spin up their own version of this tooling with Wallet Connect integrated, which works with CashNice, Zapit, and Paytaka. That's pretty much all for the ninjas.cash website. Yeah, you can take a look at the JavaScript code if you want. There's this is the logic for the minting contract with some extra JSON information for the minting params. So this is a configuration that you would swap out. This also is the rarity file for the Cash Ninjas. So if you go to the collection page and Pressure Ninja, here you see that it shows rarity information. So you would swap that out. And the viewer that we just saw here on the viewer.html, that logic is here in the viewer JavaScript file. So have fun taking a look at the code base, and let's discuss the next repo. So of course we appreciate everyone who follows our project and who has started any of our repos. We appreciate that a lot. So the next part that we could talk about is either the minting contract or the API server. Let's talk about the minting contract first. So the minting contract is also listed on the website. So if you go to the bottom, here you can see the token ID and also the minting contract that is currently in use. So it starts with a P and it is longer than a normal address. This is because this is a smart contract address using pay-to-script hash 32. So this encodes 32 bytes of information and is more secure. And smart contracts on Bitcoin Cash start with a P regularly, unless you use a token address. So let's see, this is the minting contract. And the minting contract also has extensive documentation. Let's read this. This is a multi-threaded minting contract, smart contract for the Bitcoin Cash network. The cash script code for the smart contract is in contract/mint.cash. So this is a cash script file, and the corresponding artifact at contract mint.json. The repo also includes helper functions to set up the smart contract with minting setup.js and to claim payouts with invoke payout.js. So you can see here, minting setup.js, invoke payout.js. They use this extra file generate contract.js, and here is all the contract code in a separate folder. And here it talks about the contract design. So the contract is multi-threaded. The contract design is multi-threaded, meaning multiple contract UTXOs running in parallel. This setup enables multiple simultaneous mint interactions. Clients can randomly pick one of the threads, or an application server can manage idle and active UTXOs. So this application server is the API server that we use. So you can either choose to have the API server tell clients which UTXO to use, or clients could pick one randomly. This design also means that the mint is not actually sequential, i.e. NFT number 16 can be minted before NFT number 12, depending how much each of the different threads is used. So this is important, it's like semi-sequential. Each thread mints, so if you, for example, have 20 threads, then if you mint number 16, then the next thread would be 16 plus 20, so it would be number 36 would also be minted by this thread. So it's sequential for each thread, but the threads between themselves, one thread can be used more than another. And the next item is the contract design is practical. The minting contract is designed to be practical. For example, the smart contract separates the NFT output to the user from the exchange output to ensure compatibility with different Cash Tokens wallets. So it doesn't keep PCH and NFT on the same output. The contract also has a separate payout function, instead of having a payout for each minting transaction, which would create thousands of small payouts. Lastly, it burns the minting NFT when the contract ends. This way there are no active minting NFTs remaining at the end of the contract. Then it says optimized and clean. The minting contract is optimized to be minimal in size. The redeem script is only 163 bytes. For example, the token ID is not included as a contract constructor, which saves 30 bytes in the contract size. The size for the different transactions are as follows. So the minting transaction is 505 bytes, or BitChange 539, and the payout function is 430 bytes, with the payout transaction at the end of the mint being 350 bytes. So it's like twice the size of a normal transaction, but not that much bigger. And it ends with, the contract code itself is clean and commented as to be easy auditable and serve as an example to contract creators. The contract is flexible, it allows for an optional change output and does not impose fixed hard-coded miner fees. The contract combines burn minting NFT functionality in a minimal way into the payout function. So this is more technical for people who are interested in how the smart contract works. You can simply check it out here at mint.cash, and the cachescript file is highlighted. So there's 4 arguments to the contract. It's the minting price, the increment, so the increment is the same as the number of threads, then the payout public key hash, and the maximum count, so how your collection size. So increment is the same as the number of threads, and maximum count is the same as the collection size. And there's 2 functions. One is used by the user of the contract, which is mint NFT, and the next one is payout. Payout requires a signature and a public key to be matched to this public key hash to invoke the payout. So this is done by the creator of the smart contract. And that's all. So it's 83 lines. And I hope people take a look at this to understand how to write cachescript smart contract. And here it contains information about the opcode count. It's 84 because currently there's a maximum of 201 and the byte size is 163. And currently there's a maximum of 520. So this concludes the minting contract. And lastly, I want to showcase the API server. So the API server, as you can see from just looking at the file structure, here it has Docker. So it uses Docker and it also uses JavaScript. And you can optionally deploy it to Kubernetes if you want. So here it has the installation process, which variables to configure, how to run the server, and importantly is these endpoints. So we'll check out all of them. And then some instructions on how to run the Docker image if you want to use Docker. So the API has 6 endpoints. Let's check out each of them. So this is the normal endpoint. It's just the number of NFTs minted, the minting status active, and then the NFTs available. So this API endpoint is used to display this information. So the status is active or ongoing, and the amount minted is 1,312. So this is nothing too special. So this is the mint summary. And then we have the mint endpoint. So if you actually go to the minting page and you do wallet connect, well, how does it know which of the minting threads to use? As we said, we use an API server for that. So if we go to api.ninjas.cash/mint, we will get this information back in JSON. So there's 4 items: the contract address mint, which is the P address that we talked about. Then there's the minting UTXOs, which are 25 in our case, and also the minted per UTXO. So as you can see, there's 25 minting UTXOs, and as we talked about, some have been used more than others. So this has been used 65 times, whereas this one at the bottom has only been used 42 times. So this causes some gaps in the numbers of the ninjas that have been minted, but that's not a problem. And then here it says, it tells the client which minting UTXO to use. So it says the one called 8D04. So let's take a look what this actually means if we press on the minting UTXOs. So here we get the full list, and each minting UTXO has a transaction ID and a vouch. So this is what makes up the UTXO. And then it also has the commitment. So remember, the next one to use was 8D04. So if we go to the list here at the minting NFT 8D04, you will see that it tells the user to use this minting UTXO with this transaction ID and this vouch, and that says the commitment 8D04. And you will see if we refresh this page, it says currently 8D04. If you refresh it, it says A704. So if we go back up, A704 is number 16. So what the API server does is nothing else than cycling through the different threads to show the user which one to pick. So if we refresh this again, we can now predict that the next commitment will be C204. If we refresh, scroll to the bottom, it says 5D04. So let's take a look what this is. Oh, 5D04 is just the next number. I skipped one too much ahead. So this is number 17. Sorry, this is number 16 instead of 17. So this is how the API server works with the minting endpoint. So the next endpoints are more clear what they do. It's to get the icons, the images, and the NFTs. But let's do it anyway. So here it says icons. For example, the icon of number 431, or the images. So this is the image of number 431. Then you can also have the metadata. If you go to NFTs, 431, here it has all the metadata. And lastly is the filtered metadata file. This is at the well-known endpoint. So if you go to api.ninjas.cash.wellknown, and then Bitcoin Cash metadata registry.json. Here you have the full file of all the metadata that has been released thus far. So if you press here, if you do some search and you says Ninja hashtag, you will see all the Ninja numbers that have been minted. So you see here Ninja 1552 has been minted, 551, but then the closest by is 1531. And so there's some clear gaps here. Also, you can see 1506, and the next one is 1526, so a gap of 20. So it's very important that you have an API server for this to keep the metadata filtered, so to hide and keep secret all the metadata of the future NFTs. So you can't know what the specials are for the rest of the collection. So there's no way to actually game the system in this way and to try to spot which one will be the which one will have rare traits. So that kind of concludes the explanation of all these 4 repositories. If you have any questions, don't feel free to reach out. Don't hesitate. Josh and I will be happy to help you, and we are excited to see other people use our tooling and to see a lot more cash tokens projects using this stuff. So using Wallet Connect, the Shinobi Art Engine, the OpenAI integration, and things like that. So thank you for checking out this video, and hope to see you in the next one. Bye.